We already have 28 attendees.
Yeah,
Okay.
very good.
Okay, so we're starting now with session 2. So welcome everyone. My name is Francesca Zervato and I'm a postdoc researcher at the University of St. Gallen. And today, together with Felix Manard. So hi, Felix.
Yes, hi.
So we'll be chairing session 2, social context in BPM. So before we jump into the session, Adela has prepared for us a nice video of Sevilla. So please, Adela.
Yes. I'll share my screen. Can you see the video now?
Yes, we can see it.
We are now here at the Alcazar, which is a royal palace built for the Christian king of Pedro of Castilla. The palace itself was built on the site of originally an Arab fortress, which was built here 100 years before. And before it, it was a physical site, and even before that, it was a Roman site. So you can see here really layer on layer of history built on top of each other. So the castle is most known nowadays as prime example of the Mudejar style. The Mudejar style is an adoption by the Christian kings of a style which was introduced here by the Moorish rulers of the country of Al-Andalus. And the facade behind me clearly shows the very intricate and delicate ornaments on the facades of many parts of this castle, but in particular around here.
And also something important to say is that this is the oldest palace in use in Europe. And actually our royal family, when they come to Seville, they stay here and they even celebrate royal weddings here in the palace. Now I give you back the control.
So thank you, Adela, for sharing this beautiful Alcazar. I think everyone would love to be there. So we start a nice session. We have 3 interesting papers that provide foundational results on social aspects in BPM, spanning from different angles, let's say. So we have process redesign, we have alignment of incentives, and privacy of event logs. So I'm sure that the papers will prompt a lot of questions. So just as a quick reminder to the audience, you may ask questions just from Zoom, and you can use the raise hand function if you want to turn on your microphone and ask the question yourself, or you can use the Q&A function if you want the question to be read out loud for you. So we now start with the first paper about socially aware business process redesign, authored by Arik Senderovic, and together with Joop Skippers and Hajo Rijers from Utrecht University. So Arik, please, the stage is yours.
Thank you for the introduction, Francesca, and thank you, Adelo and Hajo, for the nice video. Really interesting. So my name is Arik Senderovic. I'm from the University of Toronto, and I'm going to talk about socially aware business process redesign. It's a joint work with Joop Skippers and Hajo Rijers from Utrecht University. I will give you some motivation and present business process redesign as an optimization problem. I will then talk about what is the missing link to tie business process redesign and social aspects or social awareness. I will then formulate the social aware business process redesign problem as BPR by showing the inputs into the problem, showing the problem as a constrained optimization problem, speaking a bit about its complexity and what makes the problem hard or easy to solve. And I will conclude and talk a bit about future work. So business process redesign in a very narrow scope. We're thinking about this as-is process. It's an outpatient clinic. Patients arrive, they see the clerk, they register with the clerk, then they go to the nurse takes their vital signs, collects blood and urine samples, and sequence the patient according to either urgency or some other predefined order. And then the medical doctor examines the patient, treats the patient, and the patient checks out with the clerk. Now, essentially, we consider a design time problem, decision-making on how to reallocate these activities to different resource types to make the process more efficient, I would say. And one rule that we have here is that resource types can be added, but activities cannot be changed. So we think of business process redesign as an optimization problem. We want to select the best activity to resource type allocation that minimizes some notion of costs. This can be related to the efficiency or the effectiveness of that resource type performing the activity. We assume that the activity is performed by exactly one resource type. Of course, resource types can perform different activities. The to-be process essentially can have more resource type than the as-is, as I said. And this problem results in this activity to resource assignment or optimal matching problem that, for example, was studied in the context of business process design by Hofacker and Berserker in 2001. So that's where we start from. Now, setting up all the parameters, we can get a solution that looks like this. So we introduce a robotic swim lane resource type, and the solution would be, let's automate everything. Let's say we're now in the future where the doctors or doctor robots can examine patients, treat patients, and do the vital signs. So we potentially have empty swim lanes for clerk, nurse, and medical doctor, and we have a robot that does everything. Now, why is this an issue? In our opinion, first of all, at least not yet, not everything can be automated. Okay, so we want to understand how do we model this resource capability of performing a certain task in our model, in our framework of optimal business process redesign. Secondly, we might not want to automate everything. And here the social aspect kicks in. We might not want to eliminate all these jobs. And the question we're asking is, how do we take this into account? On a related note, we also consider the situation of the scenario of inclusion. We want to enforce inclusion or prevent exclusion of these disadvantaged resources. And by definition, if we're only efficiency driven, the optimization model will always under-prefer these resources. So a disadvantaged resource can be a human versus a machine, or an able-bodied versus a disabled human, and we want to enforce inclusion. So the research objective here was to essentially develop a decision support methodology that would be still based on optimization, just as the BPR framework I've shown you before, but would take these social aspects essentially into account. Now, what is the missing link, in our opinion, that would connect this optimization-based BPR and make it socially aware? So first of all, we want to be able to express resource capabilities, as I said, and we want to add the notion of skills. And I will show you how we do that. We want to essentially address this issue that we mentioned, that not everything can or should be automated. Automated solutions will not always have all the skills, and it may be costly to train an automated solution to perform a certain task. And of course, this also applies for humans. So in this work, we have a perfect symmetry between the machine or the algorithmic solutions and the humans. Both can have or may not have different skills. The second aspect, I mentioned that we might not want to automate everything, or we wish to enforce inclusion. So we do that by essentially adding social policy into the game. First of all, we introduce a social cost that is associated with assigning a task to a resource. So whenever I, for example, assign a certain task to a machine, I pay a certain social cost. And there is a budget which the organization or the policymaker decides upon, which is a limit on the total number, on the total social cost that I can spend per each resource type. Okay, so now I'm going to talk about these two missing links. First of all, we modeled skills using these colored directed acyclic graphs. So here we have 5 skills: S1, S2, S3, S4, S5, S6, sorry, 6 skills. S1 being clerkship, S2 being vital signs. So returning to the previous example, we have 6 skills. We see that the skill graphs are essentially shared in their structure between the 3 resource types: the clerk, the nurse, and the medical doctor. And we were inspired here by what is called career path graphs, paper by Shirani from 2019. Now, we're assuming that an activity requires exactly 1 skill in that graph. However, there's a precedence order between the skills. So in order to obtain skill S2, I must first obtain skill S1. And we assume that each resource type has a certain initial coloring that is part of the as-is description of the problem. Now, the other aspect is social policy. So each allocation of activity to a resource type is associated with a certain cost. For example, this cost can be 0 when the task is assigned to a human or a disadvantaged resource, and it can be non-zero and even infinity if a task is assigned to a machine or to an advantaged resource. And we set a social budget for each of the resources that bounds the total social cost that we allow to spend. And I'm going to formalize this in what follows next. So next I'm going to formulate the SVPR problem. What are our inputs? So there are inputs that we think of as intrinsic or endogenous to the problem. So first of all, the set of activities from the as-is process. Then we have the resource types, including the new type, for instance, our robot. And we have the task to resource assignment costs that are mostly related to efficiency. Then we add the skill graphs and the initial coloring per each of the resources. This can be obtained from professional curricula or from guidelines. And we associate costs to training to a certain skill, including implementing an algorithm. Now, the exogenous part of this problem is the social policy, the social costs and the social budgets that is going to be set by the user of our approach, by the organization, essentially. And we will see that this exogenous policy is essentially both related to how the model would look like in the 2B, but also influences the hardness, the complexity of the problem. And then the next step would be to formulate the SBPR as a constraint optimization problem. So this is no longer a simple assignment problem, and we will see that the complexity of the problem is essentially NP-complete. The problem is about minimizing an objective function. The first part of the objective function is exactly the same as it was in the original optimization problem. We're trying to be as efficient as possible. So XAR corresponds to assigning variable activity A to resource R, and W are costs related to the effectiveness or the efficiency of that assignment. Those are the X's. The Y's correspond to training resource R to obtain skill S. So these are costs that are related to training or implementing an algorithm. The next part are two sets of constraints. The first constraint set are essentially the budget constraints for each one of our resource types. And the second is that every activity needs to be assigned to exactly a single resource type. Next, we have constraints that are related to the skills. So the first skill constraint says that if we want to assign a resource to an activity and they have no corresponding skill, we need to train that resource to obtain that skill. So that's the first implication here. The second constraint is that if we assign a resource type to a certain skill, it must either have it in the initial coloring or it must have all the skills that precede that skill. So we need to obtain all the precedence relations. Essentially, this is a set of constraints that talk about the precedence relations between the skills in the skill graph. How do we solve this? So essentially, we get a constraint optimization problem. We can solve it using any standard constraint programming solver. For this problem, we formulated the problem using Minizinc and then solved it in batches via Python with a package called PyMZN. Minizinc is essentially a modeling tool where you can formulate the problem and then any out-of-the-box constraint programming solver can be plugged in and the problem can be solved. We also show that this constraint optimization problem can be converted into an integer linear program by using rules from a paper by Plastria 2002. And everything, the link to the implementation, to the Git is available in the paper. So when we apply SBPR to our hospital example, we see that we no longer have only activities and resource types. We also introduce skills, and in the result, we see that the clerk obtains a skill to sequence the patients. The RPA performs the registration and the checkout. The nurse still performs take vital signs and collect blood and urine samples. And the medical doctor examines the patients and treats the patients. So this is an example, a toy example of how we could use the tool to support decision. And we see that, for instance, patient sequencing is something that we decided against because it was too expensive to train the RPA solution to sequence patients. But of course, with machine learning and AI capabilities, this is something that can also move to that swim lane eventually. We have a theorem in the paper that says that the SBPR problem is NP-complete. The proof is pretty simple. So a special case of our problem is called the generalized assignment problem, which is known to be NP-hard, which means that the SBPR problem is at least NP-hard. However, since we can also write the problem as an integer linear program, it means that the SBPR is at most NP-complete, which proves that the problem is NP-complete, and I encourage you to read the proof in the paper. So we have a discouraging theoretical result. However, we show in the paper through an extensive computational study that empirically this problem can be solved pretty quickly using out-of-the-box solvers for problems for BPR with thousands of activities, hundreds of resource types, and hundreds of skills. The way we check it is we essentially generate random SBPR instances, and we're conducting a study that asks when is this problem becomes intractable, when what drives the complexity. And the interesting answer that you can find in the paper is that the hardness is essentially comes from our social policy. So there is a terminology that we introduce in the paper called social pressure, which is essentially the slack between the average activity assignment. If we would assign each resource, we would make a uniform resource assignment to the different activities. So when this social pressure reaches the budget, essentially when there's no slack between these assignments and the budget, the problem becomes harder and the instances become intractable, and it takes hours to solve, if at all. To conclude, we developed a decision support methodology that provides a link between business process design or redesign and social process optimization. So we make the BPR process social. And we show that the policy of allocating the budget and setting the social costs influences not only the resulting to-be models, but also the hardness of the problem. And in the future, our first to-do on our to-do list is to try and apply the methodology to a real-world organizational setting. Thank you for your attention, and I'll be happy to take questions.
Thank you.
Yep.
Thank you, Arik. So we provide some applause.
Very nice.
Nice presentation, perfectly on time.
Thanks.
So are there any questions from the audience?
Currently no questions in the question and answer tool. Maybe I can start with a question. Arik, you say the future work is to apply this methodology in a real world organizational setting. What kind of challenges do you foresee of using such computational methods to come up with this?
So thanks for the question, Felix. The main problem, as I see it, will be to estimate or to fit all the different parameters. It will probably be a very kind of intensive, iterative process, speaking to the management and understand, but also retrieving those curricula and guidelines on how work is performed and what skills are required. This is going to be pretty labor intensive, but once it's there, I think we can answer interesting questions that are related to, okay, let's set this social cost to be X and let's set the budget to be in a certain way and see how the resulting models look like. So I think that would be the interesting part that would show how these social policies influence the to-be models. The challenging part to your question would be to actually obtain all the data that we need and estimate all the parameters.
Yeah, thanks. I see Dirk wants to ask a question, so I'll let him talk. Please, go ahead.
Thank you. So I like this topic a lot. It's a very nice link. And at the same time, I never like models that are purely mathematics based, just formulas that crunch numbers. I'm a visual animal and like to kind of see how behavior plays out, right? And this is a bit also driven by what Avi said this morning in the keynote. The visual models that we have in BPM, they're very important to kind of communicate with the people, to keep the human in the loop. Do you see any way of making that happen, kind of to bring it to a visual level, this kind of reasoning? Sure, this is modeling optimization. This is not mining. I understand the difference, but is there anything we can do here to take it out of number crunching, which is always difficult to grasp, and then some number falls out of the formula, and that says that's better. And to make a more clear reasoning case for why it's better.
I see. So I think that I understand your question. You're asking if we can do some root cause analysis to understand why the result of our model tells us that we need to reallocate a certain activity to a different swim lane than it is right now, or
for example, anything that kind of explains to me, not just in terms of your mathematical modeling, because I don't understand that, why that is a better allocation.
Right. So we actually, when we experimented with the model, we had some examples, so toy but real examples of processes. And then when you look at the 2D model, you can actually start asking questions. For instance, why was this activity preferred to be assigned to a nurse and not to a doctor? Right. So you can visualize the results just like I did, but you can generalize it to, basically you can start drawing the 2D models and perhaps searching for the root cause for why the optimization model decided for one swim lane and not the other. But this is exactly the issue with these methods, right? They're trying to assist the human in tasks that cannot be simply visualized, or you cannot always get a simple intuition to why this allocation was chosen, right? So we see that these examples in planning and in optimization, where you have a plan or a solution that a human would never think of, but because there are simply too many parameters in this problem, right? This is not an easy decision making problem. Even the basic BPR or business process design problem can benefit from an optimization based approach where you just have too many parameters and decisions to be made. So you can always observe what comes out at the end of the pipeline and try to understand how the machine arrived to that, or how the optimization solver arrived to that, but that's not always trivial to kind of analyze, right? Because otherwise we would solve it ourselves in a way.
May I add something to that? What I can also imagine is that in this approach that we would be able to include a user in an interactive mode to constrain the problem. So a user may very well, in a visual sense, be enabled to lock particular tasks in particular lanes, or to even move away from solutions that the tool provides by improving or at least updating these solutions themselves. So what you have seen mostly in the presentation is the backend, but I see opportunities to have the user interact with either the specification of the problem itself or formulation of the constraints or updating the optimal solution. But that is something that is not visible in this work, which mostly focuses on the back end.
Oh, clear. Thank you.
So are there any questions? So we had a raised hand. We have that again. So from Plina. So Plina, welcome. You should be able to talk now.
Can you hear me now?
Yes, we can.
Yeah.
Okay. Hi, Eric.
Hi,
Yeah. Social aspects are really difficult to capture using optimization models. So you always have to be a bit simplistic. Anyway, in this case, you didn't consider the capacity of the resources, which of course depends on the number of running cases in parallel. And another related social trend is about fairness of allocation. And it also relates to the capacity. So can you comment on that?
Yeah, so we definitely considered both, but we decided against as this first model, that we wanted to really, for this model, to capture the social aspects and introduce skills. But we definitely discussed things like frequency of the activity being performed, what is the capacity of our resource, and so on. But here we're allocating activities to resource types, right? Once we make that decision, we can also decide how many nurses we're going to hire and how many doctors we're going to hire against the workload. So we're going to look at something like frequency of these tests that need to be made. And then according to that, using, for instance, queuing theory, just because this is something we know and like, and going to talk about on Thursday, we could potentially say how many nurses we need, right? But this is a more fundamental, this is a design problem. Who does what? It's less about the how many we need, but of course, yes, eventually we will need to say how many cores will this machine need, or how many nurses will we need, and so on. To your second question, the second question was about fairness between the resources. This is also an excellent question, and we did consider this aspect as well. So whether if I assign too many activities to doctors against nurses, but this is again an operational question. So this is again something, we have two wards, and why is one ward getting more patients than the other, and so on. This is load balancing, for instance, something that load balancing can handle. But I think that for this design problem, for this fundamental business process design, redesign problem, we left it out. We left these considerations out. But we definitely talked about it and whether this should come in at this level or not. And we decided to kind of separate the means, to separate the design problem from the operational problem.
Thanks, Zach.
Thank you.
Yeah, so thank you. I think now we need to move on with the second presentation. So thank you all for the question and answering. I remind you that if you want to continue the discussion, there will be a coffee with the authors tomorrow, I think, with Arik specifically.
Yep.
So yes, tomorrow, right? Okay. So the second paper is a work about incentive alignment of business processes, which will be co-presented by Ingo Weber and Tobias Heindl from TU Berlin. So I don't think Ingo needs introduction. So Tobias is working with Ingo, and he's an expert in model checking. So Ingo, please go ahead.
Thank you, Francesca. So let me start with a question. Why are people participating in business processes? So let me take the example of a hiring process I triggered last year when I wanted to hire Tobias as a new postdoc into my group. Why did I participate in that process? Well, because Tobias is an excellent theoretical computer scientist and I wanted to work with him. But then I passed off the documents to HR, and they processed them, and eventually a contract came out the other end, which Tobias could sign. Why did they do that? Why did HR do that? Because it's their job, right? And so this applies in many cases in the intra-organizational setting. But once we look at multi-party, collaborative, inter-organizational business processes, this is no longer the case. And of course, many of you will be familiar with my work on blockchain. And here, this problem is particularly pronounced, right? Why would anybody participate in a blockchain-based business processes? Only because they get something out of it. And so this question, do they get something out of it? Do they have the right incentives to participate in the business process? That's essentially what we're dealing with here. And I really like this topic because it goes to the core of the BPM field. What is a business process? A set of activities, et cetera, that generate some value or that allows organizations to achieve their business goals. And if we're quite honest, and in many cases, the technical research that has been done over the past decades in BPM has been quite disconnected from this part of the definition. And so here we essentially try to bridge between those areas by using game theory to check whether incentive alignment is actually given for business processes, whether the incentives align with the process. What could go wrong? So there's a classical paper from the management literature shown here. It's called On the Folly of Rewarding A While Hoping for B. So you want people to do B, but maybe it's hard to measure, or maybe for some other reasons, you really reward them when they do A and somehow hope that they will do B nevertheless. And this paper lists quite a few examples, including some from the university sector, with which many of you will be familiar. So now back to business processes. So if we look at a collaborative process model like the one shown here, then essentially we want to ensure that we reward process participants for B, right? For the thing we want them to do, namely to work towards the success of the business process overall. So how can we do this for any business process? Check that the participating organizations are actually incentivized to complete the process.
Yes, and that's a fantastic question. And I'll just explain it to you. And to illustrate the issue of whether or not people are incentivized, especially to go forward in the business process, let's look at this cooperation between a pizzeria, a delivery service, and a customer. So you kind of know how that works. In the end, you have the pizza at the customer, and it should be the case, yeah, well, actually, we just had pizza arriving. Basically, right now, I would be eating the thing. But no. So back to this talk. Yeah, so the pizza arrives at the customer, and that's great, and but also the delivery service wants to be paid off. So typically, in this setting, yeah, you know how that works, and eventually the food arrives, and yeah, the hungry customer happily eats the pizza. And then it's up to the delivery service to bring back the cash to the pizzeria. Oops, no, that's not working because, well, why should the delivery service bring back the cash? I mean, why not just store and keep the cash, right? So yeah, to understand this issue in depth, I'll review the basics and fundamentals, and then we'll see how we can fix this. Okay. I should say that, yeah, please write questions anytime. Also, ping me directly on that screen. I can look at some point. So if you have questions, just go ahead. The basics, the fundamentals. Starting with the intra-organizational, or to be precise, single lane, single pool setting, we look at activity-based costing. It's a simple idea. Each activity has a cost. Next thing, we want to be optimal, right? We had that theme already. So we want to be cost optimal. So we want to minimize costs. Out of these two building blocks, we get a strategy for how to execute our business process, to make a schedule, let's say. And that leads us someplace. And if that place is where we want to be, then we have incentive alignment with respect to this specific goal. Great. So let's have an example, a simple one. We want to do business in the city, say. And there's two ways to get there. Either we take the bus or we call a cab. So now we want to be cost minimal, and well, it doesn't take the genius of a rocket scientist to figure out we take the bus because it's cheaper. Okay, and that's great because this already gives us a strategy that's incentive aligned with respect to completion. Well, we take the bus, we get there. Fantastic. However, we already have a little surprise because essentially, calling a cab is a dead activity because it will always be too expensive according to this process. So we can just leave it out. Okay. So and that was in quick the version for intra-organizational business processes and customer optimization. Great. So typically I would ask any questions. So far so good. And I do. But so far there's no questions. So now we go for the real deal. The inter-organizational setting. And well, certain things are kind of obvious. So we have several actors, so say Alice, Bob, Eve, and each of them follows a strategy. And this gives us a strategy profile. And if that leads us to where we want to be, okay, fantastic, we have incentive alignment with respect to this goal. Great. But, well, where do we get that strategy profile from? That goes in two steps, actually. And maybe not so hard. First one is really obvious. So instead of having activity-based costing, we have what we call activity-based utilities. So each activity gets one number for how much this pays off the respective actor. Okay, that is easy. And then intuitively, we hope that things balance out. However, technically, what we want is we want to look at equilibria that we inadvertently generate by putting these utilities on the activities. So let's look at equilibria. So first thing, it's an equilibrium always gives you a list of strategies, a strategy profile. Say a at any given point in time. For Alice, Bob, and Eve, we have the actions ABC being the one proposed by the equilibrium. Then next, and most importantly, if we have an equilibrium, then it is the case that unilateral deviation from the policy, from the agreed upon strategy is punishable. For example, if Bob were to do something else than everybody said like we want to do, then in this case, Alice and Eve will know, and they will be able to punish Bob. So Bob, it would be just irrational to do something else than agreed upon. So then there's a technical, like the full formal definition actually, in terms of best responses. And in the simplest case, this means, so suppose Alice and Eve have figured out already what to do, and they know A and C is part of a choice in an equilibrium, then what Bob should do falls out as a best response to what Alice and Eve have already been thinking. And in this way, Bob can just say, okay, well, I compute and I do what we want to achieve our goals, hopefully, right? Good. So now it's time to look at our example back. So the pizzeria customer delivery service issue. And well, what you notice is that within this model, there's just no way for the pizzeria or the customer to punish the cyclist for not going forward, for stalling the process. So, you know, however, if it was an equilibrium that governs this behavior, then there would be a way to punish bad behavior, if you will. So what do we do? What's wrong? And yeah, think about it for a second. What is wrong with that model? And well, you're the cyclist, you don't give back the money, and tomorrow you come again to the pizzeria and you want to deliver another pizza. Well, that's not going to fly. The pizzeria will say, well, where's the money from yesterday? Okay, so, and to take this into the model, to fix it, we just loop the whole thing. And that's pretty much what's happening, right? So once the pizza is delivered, then again, some customer will want to have pizza, and the whole cycle starts again. Roughly, the delivery service is incentivized to go forward because of the pay of the next day, so to speak. In technical terms, we can figure out that all average payoffs in expectation for all of the participants are larger than 0. And so everybody wants to go forward. And this means that we have incentive alignment with respect to liveness. Fantastic. So now there's 2 more things to say. First, you don't want to do that by hand, right? Calculate the equilibria and whether or not they're good, whether they move the thing forward. So you want to have an incentive alignment checker. And that's, of course, future work. However, there's recent work, very recent work from Prison Games, Marta Kwiatkowska and co-workers, that does essentially the same thing. Then, the other thing we did in the paper, actually, is we have a good relation to soundness. So you might recall soundness is for workflow nets, and in particular, you have paths to completion and node transitions. And what we have is actually a very nice so-called conservative extension of soundness. That means, first, incentive alignment with respect to soundness is at least as strong as soundness, but also the converse with reasonable assumptions. Okay, and the details are in the paper, and it's really good to have this extension so that we don't make more new things than necessary. To conclude, we have this new framework for checking incentive alignment, and it's very easy. You just put utility annotations to all the tasks. Then you have several equilibria, which might not lead to the goal. If they do, hooray, you got incentive alignment with respect to the goal. So really the main contribution of the whole thing is this framework. And also we have spelled out all the game theoretic detail of what it means that incentives steer actors towards a specific goal. Okay, then the one takeaway message, just quickly, very quickly. Incentive alignment with respect to a specific goal is always better than the goal. And here we come to kind of the social aspects, because it just means that you don't have to keep tabs on people. People will just be incentivized by themselves, so to speak, and by the money that's on the line to go forward, and we will reach the goal. Finally, we have model checking techniques that we can hope to use to solve this. And it was great to give this presentation here, and I am looking forward to your questions.
Thank you.
Thank you. So thank you for the nice presentation. Are there any questions from the audience? So I don't see any question for the moment, so maybe I will start. So I think you mentioned several times in the paper this concept of utility function. So I was wondering what are the challenges of defining this utility function when you don't speak in purely economical terms, but you want to include social or ethical aspects as a reward or a payoff?
Yes, that's a very good question, and I already saw that kind of coming. So utility functions are, of course, the central topic of game theory. It's basically what made von Neumann and Morgenstern famous. And indeed, yeah, sometimes it's hard to get them. And there's just no reason to deny this fact. So you might, of course, try things like having several goals that you want to achieve and have like multiple goals, but honestly, yeah, if you can not put a number on how much this or that is worth, be it like for you personally or like in pure cash, then of course this is an issue. This might be a point where you find out that actually this might actually be just a case where this framework alone cannot cut or cannot be the answer alone. So
if I may offer sort of a different viewpoint, so in the case of this simplistic pizza delivery process, you know, why does the customer want the pizza? Let's say the pizza costs, including delivery, costs $12. And having the pizza is worth more than the $12 to the customer. So in that sense, it doesn't have to be in absolute terms. You don't need to say the pizza is worth, you know, $20 to me, but you can just say the pizza plus, you know, epsilon or whatever. This is one aspect. If it's not worth more than what you're paying for it, you shouldn't buy it. But also in terms of all the other social aspects that you were referring to in your question, maybe it's not that the framework needs to tell you everything about all the various dimensions that do exist, of course. But, you know, model is always an abstraction, of course. And therefore, maybe it's sufficient that you look first at the economical side, look at the dollar values and see what the consequence of that alone is. And then you can think about the implications of that. And if, for example, it's not incentive aligned with respect to the pure dollar values, maybe there's something else at play which makes the process work anyways. Like, for example, what I was saying initially about why does HR participate in the process? Because it's their job, and that's not shown as, you know, an individual number. They don't get 50 euros every time they successfully complete the hiring process, of course.
But then if you're modeling because you're referring to roles, so you're assuming that everyone who has that role is behaving in the same way, right?
Well, the behavior is just the usual assumption from game theory. It's just like you try to maximize the gain as quantified by the utility annotations. However, I might also want to add something. So we have a goal. So if your goal is to be, on the one hand, so the one thing is like we want to be like maximal or best or like an equilibrium with respect to utilities, so that everybody sees that they gain together like the best possible, so to speak. But you might then add to your goal just to say, yeah, and moreover, we have to also satisfy ethical guidelines so-and-so. And moreover, we want to be compliant with the rules from certificate so-and-so. And if that is part of the goal, then you might need another strategy actually to get that goal. So I would say, like, if you have clearly defined goals, besides the utility annotations, that might in some cases actually already help as well. So to be discussed, I would say, unless I am overstepping my role here.
But also utility doesn't have to be only dollar values, right? Like other things can play into that. And if you look into the literature, of course, you will find some ways of dealing with that. Among others, the utility of money, for example, is known to be non-linear. If you have, if you owe somebody $1 million, right? Or if by doing something you owe somebody $1 million, then I'm guessing you would probably care very much about that. But if you have minus $100 million already, you already have a lot of debt, you might not care so much about it. If you have plus $100 million, you might not care so much about it as you and I would in our life situations. So there's this aspect of money not having linear utility, but also other aspects which you can put into your utility calculations. It doesn't have to be only money.
Okay, thank you for the deep answer.
We have time for a question.
Yeah, very quick one, yes, I think so.
Very quickly, did you guys also look at literature of social laws in the AI literature? So where you, basically you're not trying to incentivize, you're trying to set the law such that all the agents are going to adhere to that. And then it's kind of a multi-agent literature.
Very quick answer, please.
Yeah.
Thank you for the pointer.
I don't think we did, and in the case of blockchain, for example, as I said, where the problem is particularly pronounced, you should probably not rely on those, especially if you're using public blockchain. Might be hard to enforce those laws.
Okay, I think we cut it here, and I think there's more opportunity to ask you a question as well. On that
Write an email, for example. Thank you.
Yes, yes. Thank you. So thanks for the presentation again. So I'd like to introduce our next speaker, who is Stefan Varenkrug-Petersen, to please share his screen. So Stefan is doing a PhD in Berlin together with Matthias Weidlich, and this presentation is also together with Hans van der Aar. He's already has published last year something on privacy preserving or privacy aware process mining at ICPM. So I'm very glad to see that this continues now with the presentation at BPM. The floor is yours.
Thank you very much, Felix. And thank you to everybody for joining. So as Felix told, this is joint work with Hans van der Aar and Matthias Weidlich. I will talk today about privacy preserving event log publishing with context to information. So first, we need to recapture that the whole process analytics market is now really taking off in industry. So what we are doing is becoming like a real world issue instead of something that we are just doing as academics. And at the same time, the European Union and other parts of the world are introducing new privacy regulations such as GDPR. Therefore, we have a need for anonymization methods that allow us to handle certain privacy issues. In the past already, several privacy preserving techniques were introduced. So there was work, as was mentioned by Felix, by me last year, that was presented in ICPM, but Felix also had a paper last year about applying differential private queries on data sets, and all these methods come with their special property, so they lack the preservation of context to information. With context to information, I mean, sorry, I thought I lost you. I mean, for example, timestamp and attribute values. Okay, so there's other work working on encryption that included context information, but that's another direction, so we want to go into here. So now let's have a small recapture about like the background information on privacy in general. So there's one really famous privacy guarantee that's called differential privacy. The basic idea is that you have some data and that you combine it with certain amount of noise, and then they end up with an anonymized data set. Right. But essentially, there are two different ways of doing this. So you can first collect all the data, then insert noise, and then you end up with anonymized data. Or you can introduce noise to the data of each individual at the start and then end up with a anonymized data set. So the later one is called local differential privacy. There's also one other important property that we need to consider here. So in differential privacy, there's the idea of parallel composition. So if you have a data set and you have distinct parts of the data set, if you apply mechanisms to the distinct parts of the data set and then combine them, you can come up with a final data set that has the guarantee as you gave to the other different parts, right? So this is really important thing, because if we recapture now that Felix already did work on preserving behavior with differential privacy, we just need to this work and enhance it to come up with a method that allows us to publish complete event logs with all contextual information and at the same time guaranteeing differential privacy. We did this by using our framework FIPL. So FIPL essentially has 3 steps, and at the end of these 3 steps, we will end up with a complete event log, completely guaranteed with differential privacy and therefore privacy preserving. Let's have a look at all these steps. So the first step is what is actually already in the literature. So you take an event log, you apply a query, a so-called trace variant query that generates a trace count. So you get a count of all queries that could have appeared in the original event log. It's important to note here that the query, that the trace variants that are like in the count do not have to necessarily exist prior in the event log, and also some variants that existed in the original event log may be lost in the process here, right? So we end up with this count, and at the same time, you still have your old event log, right? And you could now think about combining the non-privacy guaranteed data that you still have with the trace variants you just got that are like privatized. So this is essentially an assignment problem. So you want to assign the contextual information from the original log to the closest traces generated by the trace variant query. And then you kind of, you end up with a event log that is kind of split in half. So you have here the black part that is already anonymized, and you have the red part that is not yet anonymized. But we learned earlier that through parallel composition, if we would now anonymize this part, we would end up with an event log that's completely privacy preserving. Therefore, we can just apply local differential privacy here, right? So just add local differential privacy noise and end up with an anonymized event log. Right, and this is what we did in a proof of concept, and we applied this methodology to the subset event log. And what we found is that the runtime is highly dependent on the trace variant query, because the trace variant query and so forth can run in a well, exponential explosion of potential states, and therefore run into like extremely long runtime, right? We have also the assignment problem. The assignment problem has a complexity of n squared. So this is also like can take some time, but the whole local differential privacy part comes with a complexity of n, and therefore it's rather like possible to scale that. And we also showed in on the paper, so I will give a small hint soon. We also showed in the paper that we can preserve utility for logs, traces, and like attributes for decent privacy guarantees. So what do I mean by decent privacy guarantees here? I actually mean privacy guarantees up to epsilon equals 1, 1.5. So if you like go really high, low with the epsilon, you get a better privacy guarantee. But with this local difference privacy approach, you kind of lose nearly most of the utility. But with decent privacy guarantees, you end up with totally fine values, as I will show you next. So what you can see here is a workload analysis was done with a promoter, and the red line or the red dots represent the workload from the original log, while the blue line represent the workload that was generated with an anonymized log that was anonymized with epsilon equals 1. So as you can see, most of the trends can be preserved here. We lay out additional analysis on the utility in our paper. So let's say our sums up. With Prival, we enable the publishing of event logs with contextual information. We guarantee differential privacy. And this is important to mention here. We can tweak our framework in different ways. So, I mean, you can exchange the trace variant query that we used. So we used one that already exists, but you can think about writing new trace variant query and put them in here. And also the way that we apply local differential privacy is totally tunable to your situation. You can even think about applying different strength of guarantees to different attributes, yeah? Because you may consider certain attributes as extremely sensitive while others are not. The whole code is available on GitHub on the MIT license. And if you have any questions, feel free to ask or send me an email.
All right, thanks for the presentation. Let's also give an applause. Very well in the time. Are there any questions? I see there is
one.
Marit, yes. Feel free to ask your question. You should be able to talk.
Can you hear me?
Yes, very good.
Hi, Stefan. Hi, Felix.
Hi,
hi everyone. Very nice presentation. And actually, I have one question that why do we need trace variant part in general? Because if I have the original event log and if I want to apply local differential privacy, then trace by trace, as I understood, because you say that local differential privacy, then you apply trace variant first, then you apply local, then you assign the attributes, and then you apply local differential privacy trace by trace, right? But why do we need to apply first the trace variant part and then apply local differential privacy? Because we can directly go to apply local differential privacy trace by trace, or not?
Right, but yeah, in theory, so you need to ensure privacy for the behavior here. And you could just say that a trace is a fixed amount of events, and that the attribute is just one, the activity is just one attribute as the other attribute. And then you could apply local differential privacy to each activity, like you do it to the other attributes. However, if you take a trace variant query that is especially optimized to preserve behavior that really existed, your chances increase with having behavior in the final log that it was actually present in the original log, or at least is close, right? Because with this approach of fixing the, like taking each event and like just applying a random, it's more or less like a random coin flip. The randomized response is the name, a randomized response to the activity label, and you have a rather high chance of losing this activity label. And additionally, what is important to know is then, this is also important, not each activity, so each event type comes with the same attributes. So you would need to anonymize the activities first anyway, because then you need to decide what attributes will remain with this event and how to anonymize them. Otherwise, it would be easy for an adversary to spot which activity was the original activity label if you do not change the attributes that are in the payload depending on the new activity event type.
Yeah, I understood that. Thanks for the answer. I understood from the part which is for the data protection part. But if we see the data utility part, still the best situation for you is that you have exactly the same traces because you are doing this optimization problem. You are solving that so that you are able to assign the closest traces, original traces, to the anonymized one. And you say that the best situation for you for data utility is that you want to have the most similar ones or exactly the same ones from the data utility part.
Right.
And this can increase if you do that directly. For sure, from the data utility part, you would have better results. But from the other aspect, which is data protection, yeah, you are right. You may end up with something which is much better than applying local differential privacy.
But I'm not so sure about the data utility part, but because what could happen is the following. So assume that you always, for some reason whatsoever, in each trace, change the first activity from something like, I don't know, send invoice to receive payment or whatsoever, right? Because that would totally be possible if you just do pure local differential privacy on the activity label here. And this is very important, that this is more unlikely with a trace variant query. Even with the trace variant query that all exists, that is still a Laplacian trace variant query, and because this whole trace variant query thing is in theory something that you can tune even more to how you want it. And then so with the assignment problem thing, we also then assign like the contextual information, not just like to each trace. So you could think about insert in an event early in the trace. Let's say you have something like A, B, C, and you insert A, C, and then you have D or whatever. In your approach, then, or what you suggest, then you would kind of lack a handling what to do with the contextual information of the C event that was first in the third position and now is in the second position. So why we would reassign that to the second position. So this is something that would then be a question how to solve if you just apply local differential privacy on their activity labels, like you do it, for example, with, I don't know, the attribute or timestamps.
Yeah, thanks for the answer. I think we can discuss it for more than 1 hour. Let's others ask questions.
Yes, but very, very good. Thanks for the nice question. Are there any other questions from the attendees?
I don't see any question coming.
Okay, we have still plenty of time. Stefan was very quick in his presentation. So let me ask a question. So because you talked already a bit about, or basically this approach is very much relying on this compositional property that you can basically apply the noise on one part and then go apply the noise on the other part, and you still get the same privacy guarantee. Can you reflect a bit on, because this is, from my understanding, this relies a lot on the two databases being disjunct. So, and but in the case of event logs and attributes, they are highly likely to be highly correlated.
Yeah, that's actually
reflect a bit on that.
Actually a thing that we discussed in the discussion paper of the paper, because you can think about something like you have weight and height, and at the end you want to calculate the BMI, and like if you then apply noise independently, you may end up with a situation where you completely, like, I mean, let's say you decrease height and you increase the weight, and then you come up with far higher BMI than which is usual, which is actually an issue. But this is not unknown in the privacy literature. So I just a few weeks ago I saw a paper that is actually handling these things, because then you can think about like grouping these attributes and analyzing them as a group. But it's like still a different. This could be still like you have still this disjoint event logs, because you would consider two attributes as being disjoints of everything else.
Mm-hmm.
Like if you just take them together and anonymize them.
Yeah, because this was kind of one other follow-up question maybe would be that often in event logs you also have that let's say the subject, the one that you want to protect now, is actually part of multiple traces, for example.
This is also an issue, but there's the multiple traces. This assumption is so this actually depends on the strength of the epsilon. So we assumed in the start, so this wasn't part of the presentation, but we assumed that like each trace corresponds to one individual, and one individual is present only once in the event log. However, if you know that there are at max 3 traces corresponding to an individual, you can just tune the epsilon accordingly, because then you just need to multiply the original epsilon 3 times.
Yeah.
However, you can see this doing this for the whole event log might also be like utility preserving. So there might be strategies of batching traces and then stuff.
Yeah.
Because if you batch them and then apply the different needed strength for different batches, you come up with probably better utility.
Yeah, because in a way, if you would imagine in a hospital, you have this very, very sick patient that comes every week, and you get a new case every week, then it's of course also very unlikely that there is enough sufficient noise to hide the fact that his attributes are in the traces, right? So you will by chance have the correct ones.
But you could argue, I mean, this is now a philosophical question. So what is a trace? So it's like each visit a trace, or is the patient a trace? So
yeah. Any further questions from the audience?
Then maybe I can also ask a quick question. It's more of a curiosity. So you mentioned about like anonymizing also timestamps, like you're shifting timestamps. So I was wondering, I think you managed to maintain the order of the timestamps, but are you also maintaining the distance, like the temporal distance between them? If I would want to do conformance checking on looking for patients that have been treated within 30 minutes, would that kind of analysis work on your anonymized log?
So we have a table on the paper regarding like aggregated value about timestamps. So if you think about something like average duration and so on, so and on the aggregated level, that worked kind of. Important to notice is here that we due to the trace coherent design, we kind of lost outliers and created other outliers. So like other kind of outliers that this like influences like the overall distribution. But we on an aggregate level, we could preserve, let's say, relations. So if I remember correctly, we had like the average and the median, like in their so that I think the median was higher, or the median was lower than the average, and we preserved that, for example, for quite some time. But if you look on like a case-by-case cases, you of course run into the problem with conformance checking, that the trace current carrier that is currently employed can generate traces by itself that are obviously non-conformant, because they are obviously noise, because right now you can up with traces like receive answer, send request, receive answer, send, whatever. So completely out of order, and that is something that needs to be still handled And this can be done by thinking about, or partly, I mean, only partly because we want to insert noise. This can partly be achieved probably by rethinking about trace variant query designs, and maybe even thinking about having different trace variant queries for different use cases, like designs here. Because you can, the current approach, for example, does not preserve the overall amount of cases, right? So this can fluctuate like a lot. Like even if you have 1,000 cases at the beginning, you can end up with 5,000 or 500 or whatever. And you can think about this could be a property that you want to preserve, right? And then you would need to apply a different trace variant query, but you're like totally free to stick it in the framework, because the framework actually does not care how your trace variant query works. It just cares about that you come up with a trace variant count.
Okay. Thank you for answering that.
So very good. I think we're at the end of the session, right?
It looks like no one else dares to ask. So yeah. So thank you everyone, I think, for joining the session.
Yes, let's give a virtual applause to all the speakers again. And hope to see you at one of the next sessions. I don't know actually what the next one is. Do you know?
There is a coffee with the authors, I think.
Okay.
So probably not these authors, some authors from the morning, some...
Yeah, there is a list of specific authors. Some of the ones I have already presented, of course.
Yeah.
I want also to remind everyone that there is a quiz open regarding the videos that we are showing in the different research track sessions and the keynote. And you can go to the topic called Sevilla Quiz to answer the question, and there will be a Grand Sevilla Prize that will be announced at the end of the conference, okay? Thank you, everyone.
Thank you.
Sounds very good.
Yeah.
So go and answer.
Yeah.
We will.
Okay, bye-bye.
Thank you. Bye, everyone.
Bye.